Okay, we have right here a pretty interesting trig identity that doesn't come up that often. We've got r cosine of x plus r cosine minus x equals pi. Now, this is actually pretty easy to see just looking at a unit circle. Man, that's a terrible circle. Now, this is going to be pretty easy to see just looking at the unit circle and looking at a few values. Let's say we want the x value to be square root of 3 over 2. So the minus value, of course, is minus square root of 3 over 2. So where square root of 3 over 2 is going to happen is this is going to be at pi over 6. And for minus square root of 3 over 2, it's going to happen over here at 5 pi over 6. You add those together, 5 pi over 6 and 1 pi over 6, and that's just pi. But when you look at the graph, it really doesn't matter which point you choose. Like if you have a different x value that, say, brings us over here somewhere, well, the corresponding minus x value is going to be over here somewhere. You add those together, it's always going to be pi. Another way to look at it, when you look at the actual graph of r cosine, and then if you did it on r cosine of minus x, you can kind of see the symmetry that if you add those together, it always works out to pi. But now that's just kind of the intuition for it. Now I kind of want to look at deriving this formula more formally. And the first thing, with the r cosine minus x, you may want to use even odd functions. Well, you can't really do it because r cosine's not even or odd. You can see if it was an odd function, you get 0. If it was an even function, you'd end up with like 2, because this would be the same thing as this. And then that would be something totally, that wouldn't make sense because then this wouldn't be a constant value. So there'd be no way to get a constant value on the right side. So what I want to do on this is we'll take just cosine of t and we'll set that equal to x. And so if we take an inverse on both sides, we have t equals r cosine of x, this thing right here. And then next, let's look at cosine pi minus t. Well, this is going to be the same thing with the supplementary angle formula. This is going to be the same thing as minus cosine of t. But cosine of t is x, so we can say this is minus x. And then doing the same thing, taking the inverse on both sides, not worried about the middle part here, just taking the inverse here and here. What we're going to get is pi minus t equals r cosine of x. Sorry, r cosine of minus x. But then what we can do is we can take these two equations and add them together. Taking the right side first, if we add those together, we get r cosine of x plus r cosine minus x, the whole left side. Then adding the left side, we got t plus pi minus t. The t's cancel, and we get our solution of just pi. Probably not very good as a proof because we depend on the fact that we already know the supplementary angle formula right here. But given that we know the supplementary angle formula, this formula is going to be easy to derive. Okay, that's it for today. Thanks everyone for watching. Have a good day.